Is that can you see my screen?
Yes, I see your screen and I hear you loud and clear.
All right, great. So let's quickly dive into it.
All right, take it away.
DevOps is one of the most sought after skills today. Its flexibility makes it applicable to like almost any field you can think of. So it is worth talking about, and that's why we're diving into navigating DevOps, the principles, the practices, and cloud native synergy. Basically, how it entwines with cloud native architectures and technology itself. So this is basically a beginner-friendly introduction into DevOps. I'm here to just basically be an evangelist, to guide you through what DevOps is all about and how it connects to, cloud native practices. So Anita has already introduced me, but again, I'm Goodness, cloud DevOps engineer and a technical writer, and I'm currently working with Camify Technologies, where we are designing a tool to support Africans with ADHD. Yeah. Also an active contributor to the Set Manager CNCF community, helping them improve their documentation to, make cloud native security more accessible to developers worldwide. And when I'm not doing that, I'm deeply involved in my own personal projects. I also mentor aspiring DevOps professionals, creating YouTube content and cloud native tools as well as the broader DevOps ecosystem, basically. So let's dive in to the topic itself. Uh, so the first question is, what is DevOps? Well, I don't have a single definition for what DevOps is, by the way. But uh, DevOps isn't a single profession, right? To me, it's a result of years of experience and a combination of like multiple disciplines, right? And it's so broad that it can be broken down into various subfields. But we are not going to talk about the subfields. I think I wrote an article recently about the subfield, so you can check it out on my Medium. If you want to know what the subfields are. But DevOps isn't just about merging the development and the operations part of it, because again, DevOps is a combination of development and operations expertise. But that's not what it's all about, right? It is partly that, but to me, DevOps is a culture. It's a mind shift in how we develop, how we deploy, and how we deliver products, right? Software products. And at its core, DevOps is all about continuous improvement. If you don't have or can't develop a curious or adventurous mindset, then navigating DevOps might be somewhat challenging for you, because it's for those that are bold enough to like, experiment, learn, adapt, and always seek better ways to like do things, right? And honestly, it starts from your everyday life. It doesn't, it's not something you just like, it's something you imbibe like with continuous like habits. It's an habit, or it's a habit rather. So that's why DevOps focuses on tools, techniques, and principles that fosters collaboration between the software development team and the IT teams, automation, to streamline repetitive tasks, continuous improvement to, enhance performance and efficiency, as well as integration to like ensure smooth delivery of high quality softwares. Yeah, basically. So let's move on. Let's talk about the importance of DevOps in modern tech workflows, because I don't think there's any argument about if DevOps is important or not, but it's we might as well also like address it. So I'm going to tell you a story. Mm, it's a peculiar one because I'm sure a lot of people must have heard about this, but there was a time where we had the developers, where developers would write their codes and they will hand it over to the operations team, to deploy on their like on-premise physical servers. And this process was often characterized by things like slow feedback loops, miscommunication between the development and the operations team, and really, really, really long wait times, for the code to be deployed. So now imagine building an entire application, as a developer, from scratch, only to wait for weeks before this reaches production. And when it finally gets to when it finally gets to the time for you to deploy, the operations team, who again have not been part of the development process, they have to like figure out on their own, right, how the workings around this product, right? It already sounds like a disaster that is waiting to happen, frankly. And that's where you'd see, like, try to make it much more, pictorial. This, for example, is our developer angry because she has developed her code and she has been waiting for deployment, and deployment has not yet happened. And this is a member of the operations team being confused about what's going on. I really don't understand this code. I have to like go through the logic before going through deployment. And this is the PM and other stakeholders getting angry about the whole thing and frustrated. So things had to change, right? And that's where the advent of DevOps and its practices came into play. Now, DevOps fosters collaboration both between the development and the operations team, throughout the entire software lifestyle cycle, starting from both planning and development down to deployment and monitoring. Every step of the way, the operations team is now part of it, right? It's no longer responsible for just deployment. They are now involved in every part, right, from the start. They help define infrastructure, deployment strategies, and also scalability, right, from the onset, right, even before a single code reaches production. And that's where came a central figure, right, with knowledge on both ends, the development and the what do you call it, and the operations expertise. Not so much of development because at the end of the day, the DevOps engineer doesn't really like overly code, but basically he needs to have that experience or that knowledge. So it became essential to infuse these practices with the help of this individual called the DevOps engineer, alongside its sub-disciplines, right? So these practices now have now become deeply integrated into the creation of like modern applications and tech workflows. And it's no longer an option, it's essential. And you can see the advantages. It speaks for itself. Have seamless collaborations among teams, automation of infrastructure. So you don't have to like manually spin up infrastructure anymore. You also have fast releases with CI/CD workflows, which we'll talk about later, and also real-time monitoring and feedback, as well as scalable and flexible infrastructures that scale at will when there is a need for like additional resources. So these are some of the practices that DevOps strongly holds itself by. Let's move forward. So let us touch a bit on the various principles or practices of DevOps. And the very first one I would like to talk about is collaboration. Um, Collaboration might seem simple. You can say, I know how to collaborate, and I collaborate with a lot of people. But it's often overlooked actually by the inexperience, right? Because in DevOps or as a DevOps engineer, you have to be involved from the very beginning of the whole application or software lifecycle, right? While you are not writing the front end code or the back end code or the or any code basically for the application setup or makeup, right? You still try to present. You still try to be present, right, to ensure quality deliverables across all of the facets of the product. Now, the ability to collaborate means fostering communication, gathering and providing feedback, and also ensuring adherence to standards across all of these teams that you manage and oversee. So it's the culture of DevOps embodying these practices, especially collaboration, driving harmony between the developers, the testers, the operations teams, and the stakeholders, right? Are you with me?
It seems goodness got cut off a bit.
Uh,
Welcome back. I can hear you now.
oh, great. So where did I stop? Where did you stop hearing me? I noticed that I kind of jumped out at some point. I was talking on automation. Is that where we stopped, or is that where you stopped hearing me?
Yes.
Okay, great. So I'll continue. So I have these front end colleague that loves to like tease me about DevOps engineers, saying that they are lazy because we try to do as little as possible while achieving the most, right? But I always hit back by telling them that give a lazy person a job and they'll find a better way or an easier way to do it. And basically, DevOps finds an easier way to do things, right? DevOps engineers, they strive to automate processes in software development cycle, especially those that have to do with like repetitive and frequently run tasks, right? Now let's imagine, for example, now you want to spin up a cluster, an EKS cluster and AWS. And every time you want to spin that up, you do that manually. You have to like, let's say, spin up a VPC environment for the networking. You have to spin up load balancers. You have to spin up EC2 instances for the nodes. You have to also think about SSL as well, KMS, going to KMS to like configure keys and stuff, right? Imagine having to do this, then you have to like destroy it again. That's stressful, doing all that manually. But with tools like IEC, infrastructure as code, tools like Terraform, tools like CloudFormation, you can actually automatically create and destroy these clusters, right? And along with all of its resources without stressing yourself and to like go manually and do all that stuff. So automation does not just save time, it reduces error, it improves consistency, and allows you to focus on what matters, solving the bigger problems, making sure infrastructure is functional and the setup is great, right? Not worrying about continuously spinning up and spinning down infrastructures manually. So let's move on. That's what then another practice or principle of DevOps is the continuous improvement. And as I mentioned earlier, DevOps is about improvement. It's about striving to improve, right? So there's no such thing as perfection in DevOps, right? We're not perfectionists, right? But there's always a better way to do things. There's always a better outcome, and there's always a better result. So you have to continuously improve in DevOps, right? And that means we focus on performance, right? Enhancing the performance of like software deployment and development, while considering cost, right? It's a key factor. Cost of optimization is also a key factor there. So this is where things like CI/CD actually comes into play. CI is continuous integration, and CD is continuous deployment, right? So as the code evolves and setup evolves and deployments improve, there's need to continuously test, there's need to continuously integrate, there's need to continuously redeploy, right? And you do not want to do that manually as well, right? So that is where CI comes into play. It brings about automated testing, smooth integration, and rapid and reliable deployment. And to be sincere or to be clear, CI/CD actually sits at an intersection between what you call it, automation and continuous improvement, right? It helps teams test, build, and deploy code, right, in a faster way with fewer errors. And the last one we'll review is the customer focus. So DevOps engineers, they always have the end product in mind and who are the people that is going to use it. Because at the end of the day, you are not developing your product for yourself or for the development team to use, right? Except it's an in-company tool. If you are developing for the general public, then there has to be the end product in mind and customers or the end users in mind. So that is where performance comes to play. It's a crucial factor, and it's not just about deploying software, it's about ensuring that the software runs efficiently and smoothly and delivers that seamless experience for the end user, right? So you have to continuously monitor. That's where continuous real-time monitor comes to play, where you have testers testing. You also have a probably section of like some end users testing the infrastructure and the code itself to see if it can carry as much people as you want to carry, right? So even after and during deployment, DevOps engage in feedback loops, to gather this insight, right? These loops allows team to like refine, improve, and make sure that these products are up to standard. Yeah, basically that's I think those are the principles and practices we can take. I think there are a lot more, but we can't actually cover everything. So let's move forward. So let's now talk about how cloud native kind of empowers DevOps and basically how cloud native empowers the DevOps engineering space. So there's something that there's a rapid evolution of like software development and IT, right? And this is mostly driven by the powerful combination of DevOps and cloud native architectures, right? These concepts, they kind of go hand in hand. They continuously improve and enhance each other, While we've already explored DevOps, cloud native architectures focuses on building and managing applications that leverages the advantages of cloud computing. So it's essential that this synergy between DevOps and cloud native infrastructures come into play. So basically, they enable DevOps practices and principles using the full potential of cloud computing, provided by these technologies. Now, cloud native enhances DevOps practices, right? But I'll have you know that there was DevOps before cloud native, right? DevOps practices were there. So it's not as if without cloud native, DevOps wasn't there. But what cloud native does is that it invents new ways to implement DevOps practices, right? It makes the workflow more scalable, more automated, and more resilient. And um, some of the key technologies in cloud native, they include containers. Now you must have heard about Docker. I think Docker is that popular now. Both developers, engineers alike, they know Docker. So basically, it's a containerization tool or application that allows for creating lightweight and portable versions of applications to run on varying environments. Docker brings about flexibility and the ability to scale and the ability to run your application in portable lightweight modes instead of using VMs that take about too much resources, right? Containers or containerization technology helps reduce all that. Then you also have microservices. Previously, we had a monolithic structure where most apps had their front end and their back end, tightly held together. So a failure in one part causes a failure in another part, and other sections of the applications get tightly held together. And uh, any failure in one part brings about failure in the other parts, right? But microservices brings about an architecture where let's use, for example, an e-commerce website where you have like different sections of the application, like let's say catalog, carts, login page, the front end page. Now, those pages no longer have to be uh, tightly held together. They can stand alone as separate applications that get combined together using services, right? So basically, these applications can run on their own. One side of the application can break and still run, and the other part will still run, basically, right? So that is the idea microservice brings to play, and this has been enhanced with the use of containerization technology. Excuse me. And this has been enhanced with the use of containerization technologies like Docker. And Kubernetes actually comes into play here as well, because Kubernetes brings about or automates the scaling, deployment, and management of these applications. Instead of manually handling where and how these containers run, Kubernetes comes into play to like take over the whole thing and makes the process automated or automatic. Then we'll move about to also serverless computing. Now, this is about abstracting the underlying infrastructure. Um, it's about abstracting the underlying infrastructure of applications. So you don't have to worry about spinning up environments. The environment is already there for you. You just have to like deploy your workload into this already available environment. Examples are like Lambda functions, Google functions as well, Knative, even AWS Lambda is a managed environment. AWS Fargate is a managed environment as well, it's serverless. I also have to do also there's also the automation tools, and this involves the use of the tools like Terraform and CloudFormation as well. We also talked about CI/CD earlier, so some of the CI/CD tools that Cloud Native brings into play are Argo CD, Git Actions, and GitLab. And there's this popular, what do you call it, thought flow that is Jenkins, or was Jenkins existing cloud native before the cloud native era? I think yes. I think from the research I made, I think yes. Jenkins or CI/CD before the cloud native era, but Argo CD, Git Actions, and GitLab CI/CD actually topped it up a notch or bumped it up a notch, and the advent of cloud native era also bumped up Jenkins technology up a notch as well. So why does this matter? Well, in today's world, you can't actually discuss DevOps, right, without mentioning cloud native tools and architectures, because the tools that are often referred to as DevOps tools in today's world are actually a product of the cloud native era. And me as a developer, or me as a DevOps engineer or a cloud engineer from this cloud native era can't actually separate. And that is the reason why I kind of refer to myself as a cloud DevOps engineer, because these tools are inseparable. I use them together, and I don't think I can separate them. So cloud native doesn't just support DevOps; it kind of supercharges it. It enables the teams to deliver faster, scale smarter, reduce operational complexity, and all that, right? And in today's world, if you look at DevOps and you take out cloud native, it's basically like driving a car without a GPS or automatic transition, right? It's going to get you to wherever you want to go to, but it's going to be less efficient. Imagine having to drive a car like a manual car these days. Even sports cars these days have like multiple modes. They don't have just the manual modes anymore, right? So let's move forward. Let's look at the career roadmap. If you want to get started with DevOps, what you need to do, how you need to, navigate it. The first thing I would advise is that you learn a programming language. There's this misconception that people say, it's DevOps. I don't need a programming language, or you wouldn't need a programming language. Well, I think that's wrong because personally, from my own development, I started learning JavaScript, before moving on to like going into DevOps or cloud engineering. So understanding the basics of web development is actually helpful and has helped me immensely. There was this time where I was given a workload early on in my DevOps career, and I was trying to, deploy it. I was trying to like put it into a Docker container, and the environment variables were not running. Rather, we're not merging at runtime, right? If I try to build, it fails. It failed rather. So I had to like troubleshoot and check. And that's when I found out that, the environment variables are actually tightly coupled to the code. So I couldn't separate it within the Docker container. I had to like join it together, which was like wrong practice. But if I had not known how to troubleshoot or use web development programming languages like JavaScript and Node.js, I would have been hung up to dry and not known exactly what was causing it, being confused and all. So you can start simple, start with HTML and CSS. You don't have to go too deep into the whole thing, right? But learning JavaScript helps. You can also learn Python because apart from Python being able to like, apart from using Python for web development, you can also use it for scripting and automation, right? If you are ready to like go deeper, you can also learn, Golang. It's quite popular, but don't learn everything at once. Don't be a jack of all trades. Pick one first of all, learn, master, and you move on, right? And after that, you should really look at version control. It's at the moment it's like a do without. It's like something you can't do without, rather, right? It's one of the most fundamental skills in DevOps, uh, and it's widely used for things like tracking changes. So basically, if you have like an infrastructure where you are coding, you can actually record previous steps you took, right, and revert back to those steps. So it helps you track your changes. It also helps you collaboration because you now have multiple people that can work on the same project and not override each other's changes with the help of version control. And Git is the most popular one. You also have disaster recovery. You can actually bring back code if something breaks. You can roll back to an older version, basically. And you also have to understand the networking basics. Learn about networking, learn about security, learn about how to configure firewalls, learn about how to configure, CEDAR ranges, subnetting, IP addresses, learn about the OSI model, the layers, the 7 layers, learn about how ports and protocols, go hand in hand. We already talked about containerization technologies, so you also have to learn that. Then also pick a cloud platform, and I said pick one first, right? You can do the others later, but pick one. Don't be a jack of all trades. Don't say I want to learn AWS, GCP, Azure, Alibaba Cloud, DigitalOcean. Don't say you want to learn everything at the same time, right? It gets confusing because there's a lot to learn even in a single cloud platform. I favor AWS. So for example, picking AWS and learning it, probably getting a certification, helps before moving on to like trying other cloud platforms. You have a lifetime to learn, all of them. You can also explore using infrastructure as code tools, right, as well, like Terraform, Ansible, right. You have to actually learn that as well. Then you also have to learn CI/CD using tools like Jenkins, Git Actions, and GitLab as well as Argo CD. Yeah. So after that, you still have to keep on improving. You have to stay updated with trends because there's always something new. There's always something that's going to be new. There's always the next step. There's always the next technology. So you have to stay updated so you don't get washed out. So if you want to learn, these are some of the learning resources that I could profile. We have the free camp code. I used that early on. YouTube is free and it has a lot of information and a lot of what you call it channels. Even a channel like Mine Cloud Folklore, we teach and we talk about DevOps and cloud related stuff. So you can actually up on it and check it out as well. You can learn using Udemy. I got my first course on Udemy for free. So I'm not saying you should go and hunt for free courses. Please pay, right? You will see the ones that are free. You see the ones that you have to pay for. Pay, learn. Then also using the official documentation of like these tools also helps. If you are good with documentation, you know how to like navigate. You could also read the official documentation. I'm not saying read it like a Bible and read everything, but you can cite things. Look for exactly what you want to. Like for example, let's say you want to spin up a cluster, you can go to the Kubernetes documentation and check how to do that. If you want to spin up, let's say, Minikube, you can go there and check it out, right? And you can also join communities where they discuss about DevOps and cloud related stuff. I like using Reddit, our DevOps subreddits as well. It's nice. There are a lot of discussions on there. Also, the HashiCorp community, the CNCF Slack is a no-brainer as well. Then, if you like Anson Labs, you could use Katakoda, which is now owned by O'Reilly. I think they kind of migrated to O'Reilly in 2019, or rather, O'Reilly bought it in 2019. I also have the AWS Cloud Skills Builder. You also have Play with Docker and Play with Kubernetes and some labs as well. Then you could also go into project-based learning. It's actually a no-brainer. You could actually learn how to do challenges. There are these challenges that always comes up on the internet. You see somebody talking about 30 days of DevOps, revamp your CV, those kind of challenges. You just build along with them. You can also do open source contributions. While it's free, it can be rewarding as well. And you can also join internships, even the ones that are not paid, right? I like money, but I had to work for free, and it was actually helpful, ramping up my skills and all. Yeah, I think that's it. Let's move forward. So I think we're at the point where the major takeaways is that you should just keep on learning. DevOps actually streamlines collaboration and delivery. Cloud native tools enhance DevOps practices, and start small. Don't focus on too many things at a time. Take the steps. We'll go back to the roadmap. Learn one at a time. You can't go over all this in 6 months. I don't think it's possible. Like you can use a year, 6 months. Like take your time, learn. I know people are talking about I got a job here, I got this there, and at this point in my career, but I think you shouldn't be don't get too choked up in other people's journey. Everybody's journey is different and separate. So you take your own journey and have fun and make do with it, and also have the best of fun and the best of time whilst advancing your skills. Yeah, I think I can take questions now. Yeah, if there are any questions.
Thank you, goodness, for that awesome session. Honestly, I think this took me down like the entire journey on why we even have DevOps in the first place, right? Because I'm just imagining how people used to deal with development when there was like a break and there was no continuity from the ideation down to delivery and all of that. Like how exhausting the whole process would have been without something like DevOps. And it's really amazing to see how it's a lot easier. And the truth is, every new technology and every new introduction comes with its challenges, but DevOps has done a whole lot of good to software development, and it's amazing to hear this from yourself. Goodness, thank you so much for that awesome presentation.
Yeah, thank you.
So
Thank you. I personally feel like it has brought a lot of improvements, even before the whole cloud native era. Um, the advent of VMs, virtual machines, install and alternating with like on-prem servers and all that, that was actually an improvement in those times. And I'm happy I was not a DevOps engineer then, but there was still improvement as at then.
thank you so much. So if you have any questions for this particular topic or for goodness regarding DevOps or all that you have learned so far, or any topic you think or any area that you think that you should stress more on, it would be great to drop in the chat. If you also come up with or think of a question much later, you can also connect with goodness on like a social media platform provided here. So thank you so much for that.
Yeah, so I just want to say it was lovely giving this talk. I was trying to like be in speed mode because I know I had like a timeline, so I was trying to like abide by the time, my 30 minutes talk time, and not go over the limits, right? So this is my LinkedIn. If you want to connect with me, this is my Twitter at BusyBrainX99. This is where I write articles. I write really interesting articles, so you can read up as well. And if you want to join my YouTube channel, it's at Cloud Folklore. So do well to connect. I'm happy to talk. I'm happy to mentor as well, and tutor. So thank you for the opportunity, and it was lovely having this talk with you guys.
Awesome. Well, thank you so much. And if there are no questions, for goodness